ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Visible light is made up of 7 colors. Rainbow is formed when the sunlight undergoes dispersion within the water droplets in the atmosphere. The light passing through a prism will undergo dispersion and split up into its component colors. Can we transform these component colors back into white light? Let's do an activity to find out. Pass the white light through a prism and obtain the constituent colors on a screen. Now, place a similar prism next to the first one in the inverted position. Here, the component colors emerging from the first prism passes through the second prism again. Here, we can see that the white light or the composite light is emerging from the second prism. So, we can understand that when the composite light is passed through a prism, it splits up into its component colors, and when these component colors again pass through an inverted prism, they transform back to the composite light. This is an interesting phenomenon, isn't it? When 7 colors combine together, it forms the white light. Now, let's see how to make a color disc. A color disc can be made by painting 7 colors, vibgyor, in a disc, which are the constituent or component colors of the white light in the same order and proportion. This disc was designed by Sir Isaac Newton, hence it is also known as Newton's color disc. How does the disc appear when rotated fast? Yes, the disc appears white. When the disc rotates fast, the components joins or appear to bend together to form the white color. The disc contains 7 colors, but we couldn't differentiate them while rotating the disc. The disc appears white due to the persistence of vision. When an object is viewed by a person, its image remains in the retina of the eye for a time interval of 0.065 seconds or 1/16 seconds after seeing it. If more than one scene is viewed within 0.065 seconds, the effect of all these scenes will be felt by the eye simultaneously. So, the disc appears white since all the rays of light from the 7 colors reaches the retina of the eye within 0.065 seconds. We can find many real-life examples of persistence of vision. Have you ever been in bed looking at a fan spinning? We can distinguish its leaves only when the fan is spinning at a low speed. When it spins fast, we can only observe a disc-like structure. This explains the persistence of vision. If we light an agarbatti and rotate it at a very high speed, the tip appears as an illuminating circle. When drawn papers are flipped over quickly, the drawings pass quickly and we feel them like a continuous video. The real videos and cinemas are very similar to this. They are really fast-moving images. Many images feel like a moving video when they quickly appear and change. That is, when multiple images pass through the retina within 0.065 seconds, they feel like moving images or video. If you want to understand it clearly, you just have to copy a scene from the TV on your mobile camera, and then you can see that there are cuts in the video that we took because the pictures are changing too fast. We know that the light travels in a straight line. Although the light travels in a straight line, we receive light during the day in the classroom and inside the home, right? Have you ever wondered why this happens? Let's see. When sunlight passes through the atmosphere, rays of light are reflected and scattered by tiny particles of the atmosphere, such as dust particles and molecules. The scattering is irregular. Light gets reflected in random directions. This is known as scattering. Scattering is the change in direction brought out by the irregular and partial reflection of light when it hits the particles of the medium. So, the distribution of sunlight to all the regions made possible by the scattering. Do all the colors of the sunlight undergo the same amount of scattering? Let's see. 3/4 of water is taken in a beaker as shown here. Allow the light from a torch to fall on the water from one side of the beaker. The light emerging from the beaker is focused on a white screen. Sodium thiosulfate is dissolved in water at a rate of 2 grams per liter. Add 1 or 2 drops of hydrochloric acid to the water in the beaker. What are the gradual changes in the color of light in the solution and in the screen? Yes, when hydrochloric acid was added to the solution, blue color spreaded first in the solution. When sodium thiosulfate reacts with hydrochloric acid, colloidal sulfur is precipitated. Light collides with these particles and gets scattered. This makes the color of the solution blue. Here, blue undergoes the most scattering. So, blue appeared at first. Then the colors is gradually changing from blue to yellow, orange and then to red. Since red has a higher wavelength, it undergoes the least scattering. That's the reason why the red color remained and appeared to the last. At the end, colloidal sulfur combines together to form bigger sulfur particles. As the particle size increases, the nature of scattering changes. Each color undergoes scattering in the same amount. That's the reason why the solution appeared grey at the end. From here, we can understand that since violet has the shortest wavelength, it undergoes more scattering, and since red has the longest wavelength, it undergoes less scattering. And the rate of scattering and the size of the particle are interrelated. As the size of the particle increases, the rate of scattering also increases. If the size of the particle is greater than the wavelength of the light, then the scattering will be the same for all the colors. So, we are learning about many phenomena of light and found in nature and understand the secret behind them. Sunrise and sunset are our favorite sights. During sunset, the horizon appears to have a red color. What may be the reason behind this? Let's analyze a figure for a better understanding. Here, it is clear that during sunrise and sunset, sunlight has to travel a greater distance through the atmosphere before reaching the eyes of an observer on the earth. As sunlight passes through the atmosphere, violet, indigo and blue colors undergo maximum scattering due to its shorter wavelength. On the other hand, orange and red colors undergo minimum scattering due to their longer wavelength. So, during sunrise and sunset, light reaching from the horizon has to travel a longer distance through the atmosphere. During this long journey, colors of shorter wavelengths such as violet and blue would be almost fully lost due to scattering. But the red light, which undergoes only a small amount of scattering, reaches our eye and hence decides the color of the horizon. That's the reason why sun appears red during sunrise and sunset. Now, you may have understood why red color has been given to the tail lamp of vehicles and signal lights. Red light has a longer wavelength, so it won't be lost due to scattering over a long distance. So, the drivers and passengers can observe the red light clearly from a very long and sufficient distance. So, in this session, we have learned the scattering of light, persistence of vision of eye, and the reason behind the appearance of red in horizon during sunrise and sunset.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.